LISI is a worldwide company specialising in the design and manufacturing of assembly solutions. So LISI has over 9,600 employees spread across 44 industrial sites, expanding over 13 different countries. LISI is split into 3 divisions, so there's LISI Aerospace, LISI Automotive and LISI Medical. So here at LISI Rugby, I manage a department called High Volume. The High Volume department is a fast-paced, busy manufacturing environment producing titanium aerospace fasteners. I feel the strength of Rugby is we are flexible and we are able to adapt to change linked to any new demands from changing climate and from the customer.
So over the last 6 years, we've developed a really great relationship with the team here at LISI Aerospace. We've taken a consultative and supportive approach to essentially understanding their engineering challenges and the problems they face and finding ways to implement additive manufacturing within the business to solve some of those problems and some of those challenges.
We use our Markforged 3D printers for day-to-day printing of the tooling that we use on our machines, as well as prototyping of the components that we try to sort of introduce into our regular production, but also components that can be used as a different help, aid and improvements in the production lines.
The Markforged technology is an ideal solution for engineers who just want a tool that works. Something that's reliable, gives them consistent throughput, but also good quality parts. The combination of materials like onyx and carbon fibre reinforcement allow the team here at LISI Aerospace to look at pushing the boundaries of what you can do with polymer additive manufacturing. For example, they're taking parts that were traditionally machined in metal, outsourced and printing them.
One of the benefits is definitely that we can print things on site. We're not dependent on the suppliers. Normally, in the previous versions, how we would develop the components would be that we would have to go back to the supplier with the ready design. Then they would have to give us the quote. We would have to approve the quote internally, and then we would have to wait on average about 2 to 4 weeks to get the component. Nowadays, it takes much less time because we can design things on site. We can then upload it into IGA, which is a slicing software. Very intuitive, very simple. Everyone can use it. So within 2 to 10 hours, depending on the complexity on the component, we can get that item and we can either put that on the machine or we can just verify that if this is a prototyping model.
So the big advantages I've found is we've incorporated Onyx 3D printing into our tooling supply point systems. All the 3D printed tooling components are available to operators on the shop floor. They have access to the supply point. The advantage of using the supply point for the 3D printed tooling is we never have stockouts. The system controls the stock levels and notifies the engineer when 3D printed components are running low. Parts are then 3D printed.
What Markforged have created is a completely scalable platform. So with software like IGA, they're able to implement that across any site within any location. And that's what works really great for LISI Aerospace, is that they've set up here in the UK. But with IGA and Markforged, they can apply that kind of additive manufacturing across any other location within the world.
Nowadays, we live in a world where technology is growing very fast. So we really have to go along with it, or we just stay behind the competition. If we didn't follow that, we wouldn't be able to produce the best possible components and give our customers the best product they really want. So with the reinforcements we can apply on the Markforged 3D printers, we obviously increase the scope of the works and the prototypes that we could apply on our shop floor as well as in the offices.
The big advantage of using the Markforged printers is the material is much cheaper, printing is faster compared to the old ways of manufacturing the parts made of metal using external suppliers. Reduce the overall spend on tooling where 3D printing has been possible, and overall the list is endless. I feel we only have just scratched the surface on things we can improve in the manufacturing processes at LISI.